another session of this sequence and series chapter. I hope you people are listening, receiving proper audio and video. Are you, students? Am I? Yes. Good. Yes. Video quality also. If some issue is there, please tell us whenever any issue is there. Without any delay, attendance part will. I have created a post in a stream tab in Google Classroom. You can register your presence within the duration of this class. Okay? बाद में नहीं. Okay. Then on the last turn in the yesterday's class, we discussed geometric progression concept. And let us have a quick revision, very quick revision. Geometric progression, we call such kind of series like 2, 4, 6, 8. No, this is not GP. 2, 4, 8, 16, 32, 64, etc. Or 3, -9, 27, -81, etc. Where the ratio between two consecutive terms remains fixed, constant. Such progression is known as geometric progression. A general geometric progression can be written as, what is the way of writing general geometric progression? AR square, AR cube, etc. Its nth term we discussed. Nth term is AR raised to power n minus 1. This was nth term. Sum of first n terms. What was that? Sum of first n terms. Aditya Bargujar, I can see you. Aditya, can you tell me what was the sum of first n terms? Students, what was the sum of first n terms? Super simple formula it is. Are you saying this? This? Huh? -1. This is, है ना? तो हम जल्दी में बोलते हैं कई बार -1 ऐसा लगता है कि power of r है, नहीं, अलग है ना? So this is. And also we discussed that if any GP, for any GP in this kind of GP, if magnitude r is strictly less than 1, means point of 0.5, 0.3, 0.1, like that, then you can see that these next coming terms will get smaller and smaller and further more smaller. And in that case, sum of all infinite many terms, if you find, it will not be infinity, it will be a finite number. And sum of infinite terms, a plus ar square plus etc. is given by a certain formula, and the formula is a upon 1 minus r. Right? This also we discussed. Then if three numbers, next thing we discussed, if three numbers a, b, c are in GP, then b is called as GM, geometric mean of a and c, and GM is given by b equals to root AC. This also we saw, right? And one more result we discussed. Satyanarayan Bairwa, can you tell me what was the AM, GM, HM inequality? One more result, students, you remember? Result which was the relation between AM, GM and HM. HM kya hota hai? That also we'll revise, but let me write the first result. AM was found greater or equal to GM was greater or equal to HM. This very useful tool result we got yesterday. And what is HM or harmonic mean? That also have a revision. Let us take the revision. Harmonic mean, suppose A and B and C are in HP. Harmonic progression. Harmonic progression, if three numbers are in harmonic progression, it means that they are inverses. Means 1 upon A, 1 upon B and 1 upon C are in AP, are in arithmetic progression. And using this, we got that B equals to 2AC upon A plus C. So this is called as harmonic mean between A and C. A and C. So if you have to calculate the harmonic mean of two quantities, the formula is this, twice AC upon A plus C. Right? This we saw. These things we discussed mainly in this exercise. We need term n of GP and Sn, sum of first n terms of GP. These formula we will need I think we are now ready to continue. Chavi Sharma, will you read the next question of current exercise? Chavi, 9.3 exercise. In the last class, till what question we discussed? Chavi, students, other students also can tell. 17th, I think first page questions. I remember I gave to you to complete because some of the questions I skipped for you people. I think 18th can be done. Chavi, can you read 18th question? Yes. Any issue? Any problem? Neitra Narsimhan, will you? I request, my dears, to be ready with your notebooks and textbooks so that when I call your name, there should not be wastage of a single second. Chavi Sharma is not there. Netra Narsimhan, are you there from A section now, right now? Ayushi Verma, yes. Ayushi, can you read the question? 18th, yes. Okay. Okay. N terms, right? Okay. Sum of N terms. So students, yeah, Ayushi, you only tell, is this a GP? Because GP exercise में इसलिए पूछ रहा हूँ, is this a geometric progression? हाँ? Check करें, ratio निकालते हैं. Term 2 upon term 1, how much here? 11 it is. And term 3 upon term 2 कितना यहाँ पे? Triple 1 upon 11. And this is not same as 11. Am I right? Correct. It's not a GP. The notable thing is that not a GP it is. So don't apply SN formula because you won't be able to find R, the fixed ratio. So if not a GP, then what can be done? Special method. So this question is a bit different from others. We have to apply some special arrangement for this. Let me write S equal to just add them all, 8 plus 88 plus 888 plus up to N terms. And 8 can be taken common. What is the overall planning? Overall planning is that we will write these things in terms of 10 or 100 or 1000, like that. So 8, let us see how it will be done. 8 I'm going to take common, and in the bracket I'll have 1 plus 11 plus 111 plus etc. N terms. Now if I write 10 plus 1, 100 plus 11, 1000 plus 111, that also 1, 11, 111, that doesn't make any proper sequence. So instead of that, I'm going to create 9. 9 I can create here. How? By dividing 9 by outside and multiplying 9 inside. अब 9 से मुझे क्या फायदा होगा वो आप देख पाएंगे अगले स्टेप में. 9, my target is that only. I want to bring 10 or 100 or thousands, because 10, 100, 1000, that is a GP. Now my target is to bring 10 or higher powers of 10. So 9 I'll write, obviously 9 you can write 10 minus 1. 99 you can write 100 minus 1, yes. And so obviously 999 can be written as 1000 minus 1, etc., and N terms will be there and brackets will be there. I think now the next step should be clear to you all. Now I am going to keep them together, the powers of 10, 100, 1000, etc. together. So this will become 8 upon 9, and in a bracket 10 plus 100 plus 1000 plus obviously N terms, minus what next? What more should be there? 1 minus 1 minus 1 minus 1 n times. How much? Minus n. And this is a GP some formula, Sn formula can be applied. Sn is equal to a r raised to power n minus 1 upon r minus 1. So this will become 8 upon 9. And let's apply this GP some formula, 10. R is also 10 to power n minus 1 upon 10 minus 1 minus n. And this is my final answer. You can check it, right? This is my final answer. 8 upon 9, 10 upon 9, 10 raised to power n minus 1 minus n. Right? This already is simple only. Even if you multiply, it doesn't become better. Right? You can check it, students. This we can declare as final answer. Yes. Now, let's move ahead towards the next question. Somebody please read the next question. Ankit Jangid, roll number 4, 11th A. Will you read the next question? Ankit Jangid, I have one. Yes, Ankit. Yes, 19th question. 19th, right? Yes. Next sequence was what? Then 128, 64, 32, 8, 2. So, comma 1 by 2. 5, 1 by 2. So I have to find the sum of the products of these two sequences. It means that we will first find the corresponding terms multiplied. First we'll multiply them and then let us see what will happen. If I multiply sequence 1 it is and sequence 2, both are GPs, GP1 and GP2. Let us multiply their respective terms and this will become 256, 128 and 64 and 32 and 16. This is, and you can see that this also finally a GP. GP it is, right? If it is a GP, it's common ratio we can tell, and that ratio is 128 upon 256, which is 1 by 2. तो एक बात और यहाँ पे हमने सीखी कि अगर हम दो GPs लें, उनके रिस्पेक्टिव टर्म्स मल्टीप्लाई करें तो हमको रिजल्टेंट सीक्वेंस क्या मिलेगा? GP, right? That somebody can ask you that as a multiple choice question, you can tell the respective terms. If you multiply of two GPs, finally you get a GP. Now I have to get the sum of these terms, so I can apply. How many terms I have? 5 terms I have. So S5 will be A 1 minus R to power n upon 1 minus R. Very easily you can apply this formula. And it can be simplified. 1 minus half is half, 2. This you can simplify, students. And you can check your answer. है ना? Not visible? Right. So simple only this is. Please complete, students. Moving towards C section, somebody let me catch someone. C section. Aman Khan, are you there listening me? Aman Khan or Mohammad Abid?
Abid, yes sir.
Abid, क्या हाल चाल है?
सर अच्छा.
गुड. आगे बढ़े. 20th क्वेश्चन आप पढ़ेंगे. आप 20th क्वेश्चन.
Yes sir.
यस.
Show that the products of the corresponding terms of the sequence A, AR, AR square.
Capitals or small letters?
Sir, small letters.
Okay.
So फिर dot AR n minus 1, AR to the power n minus 1.
Okay.
And sir और भी एक क्वेश्चन आ गया.
Yes, please.
And A, AR, AR square.
Capitals में, right?
Yes sir.
Yes. Yes.
Form a GP and find the common ratio.
Okay, so we have to prove that the corresponding terms you multiply new sequence. So Abid, can you tell what should be the new sequence if I multiply the corresponding terms of these two GPs? Huh? If I multiply, the new sequence will be A capital A, AR capital A capital R, and AR square capital A capital R square. This will be resulting sequence, new sequence. And I have to show that it is a GP, so you can show that the corresponding the ratio between term 2 and term 1, let us find, and term 3 and term 2, let us find, and we can declare. So let us find the ratio of term 2 upon term 1. Term 2 AR capital A capital R upon AA. So this is R capital R into capital R. And similarly, term 3 upon term 2 also you can find out. Term 3 AR square capital A capital R square upon AR capital A capital R. This also can be simplified. Right? R capital R will be there. So here the ratio is fixed. It proves that. So T2 upon T1 equal to T3 upon T2 equal to T4 upon T3, etc. can be proved, right? Similarly, we can write. So it is a GP. And the fixed ratio is how much? This is R into capital R. Hello, students, simple. So the same thing like previous question, but in general two GPs are given and we proved. Om Mahajan, will you read the next question? 21st, this was 20th question. 21st question. Om Mahajan, Shivam or Shubham Meena, any one of these three people. Om Mahajan, are you there active from C section? No response. My dears, I request multiple times that my dears, please be ready with your notebook, textbook, active, energetic at the receiving end. If you're not active or energetic, you'll not get the things. Edwin Joseph can read. Yes, Edwin. 1 minute, 1 minute, 1 minute. 1 minute, Edwin. Let me note this information. Repeat. Repeat. 1 minute. Let the GP is, how many terms I have to mark, right? 4 numbers. So in GP, right? So I have assumed the 4 numbers in GP. Okay. Now next. Means given that T3 is equal to, from which term? T1 plus 9 means AR square is equal to A plus 9. Okay, equation 1. Next. By 18. So also given that second term, which means AR is equal to AR cube plus 18. This is my equation number 2. Now suggest, Edwin, that how to solve. Anything else is given or this much only? This much only means because two variables, A and R, and two equations. So information is sufficient. Can you suggest that how to solve these two equations? Divide, correct. But divide करूंगा, लेकिन मैं काम करता हूँ पहले this A, let me take with AR square, and A I'll take common, in bracket I'll get R square minus 1, and here also AR, let me take common, in bracket I'll get 1 minus R square. So cancel हो जाएंगे. तो थोड़ा सा simplify कर लेता हूँ मैं. This becomes A R square minus 1 equal to 9, and the next equation 2 becomes AR common 1 minus R square equal to 18. Equation 4 and equation 3. Now let us divide 3 upon 4. Let us do 3 by 4. This becomes 1 by 2. Here minus 1 will remain. A upon minus AR equal to 1 by 2. It means that R is equal to minus 2. Here I get R value. R value you can substitute in equation 1 and you can get A. So 3A is equal to 9. It means A is equal to 3. I got my A, I got my R. Numbers I can tell, right? Because the numbers are A, AR, AR square, AR cube, etc. So let us write. So numbers are A, which means 3, then A into R, minus 6, then A into R square, 12, then minus 24. Right, students? Check the answer. Is this right? I hope it should be right. Yes. Yes. Now, Neha or Netra, any one of these two, can you read the next 22nd question from A section? Yes. कौन नेहा और नेत्रा? दोनों ही एक्टिव हैं. Very good. Neha, can you read the next 22nd question? Neha, please. Uh, 1 minute. 1 minute. Pth, Qth, and Rth terms are A, B, C. TP, TQ, TR is A, B, and C. Okay. 1. Okay. And these Pth, Qth, and Rth terms are of a GP. So let me assume first of all a GP. Which question it was? 21st or 22nd? 22nd. So first of all, let me assume the GP. And note that very important thing, often people make a mistake because we have a habit of writing first term as A and common ratio as R. But A and R has been used for some other purpose. So please use A first term and common ratio something else, and not small a or a small case R. So this is very important. If you make a mistake, the whole thing will be a mess. So let the GP is, मैं capitals ले लेता हूँ. A, AR, AR square, etc. Or any other variable you can take. Now, given that term P is equal to A, let me write term P. Term P is capital A, R to power P minus 1. Similarly, B is term Q. term q will be a r to power q minus 1, and rth term is c. So this will be a capital R raised to power small r minus 1. Okay. Now, this is the multiplication of three factors. So, let us put the value of a, b, and c. Right, it will automatically come 1. So, एक और चीज है कि हम साइक्लिक ऑर्डर में गेस भी कर सकते हैं सिर्फ टर्म फर्स्ट फैक्टर लेके फैक्टर 1 मैं ले लेता हूं सपोज a q माइनस r, इसको मैं सिंप्लीफाई कर लेता हूं पहले पुटिंग द वैल्यू ऑफ a कैपिटल R कैपिटल A कैपिटल R रेज्ड टू पावर p minus 1 whole power q minus r. This will become capital A q minus r into capital R power to power, then powers get multiplied, multiply them, pq minus q plus r minus pr. Okay, then similarly b to power r minus p and c to power p minus q we can write similarly. You know students how? See, p, q and r, they are rotating in cyclic order, है ना? So if you want to write similarly, it can be done like this, capital A q minus r, then q के बाद क्या आ रहा है next r, then it should be r minus r के बाद next क्या आ रहा है p, r minus p into capital R raised to power p, where p was there, p के बाद q, तो p into q will become p के प्लेस में q and q के प्लेस में r minus q के प्लेस में q के बाद नेक्स्ट है r प्लस r के बाद नेक्स्ट है p माइनस p के बाद नेक्स्ट है q एंड r के बाद नेक्स्ट है p. इस तरह से आप सिमिलरली करके भी लिख सकते हैं, है ना, बिना क्योंकि क्यों मल्टीप्लाई करें. a p minus q it will be and r p minus p plus q minus r q. This it will become. Now you multiply them together, and if you multiply, let us see what will happen. So a to power q minus r into b to power r minus p into c to power p minus q equals to, and let me simplify, write directly. These things you will multiply, then these bases are same, so their powers will get added. So q minus r plus r minus p plus p minus q into r raised to power, these powers also will get added. So r raised to power pq minus q plus r minus pr plus qr minus r plus p minus qp plus rp minus p plus q minus rq. Simplify, and as our target is 1, means the powers all should become 0. Q minus q, p minus p, r minus r equals to a raised to power 0 into r raised to power pq, somewhere minus pq should be there, this is minus qp, plus qr minus rq minus pr plus rp minus q plus r minus r plus p minus p, r raised to power 0. This is 1, right? So this is, ये मेरा साइक्लिक ऑर्डर में रोटेट करना आपको समझ आया तो अच्छा, नहीं तो इसको मल्टीप्लाई करना, सिमिलरली बी टर्म को और सी टर्म को मल्टीप्लाई करना, सारी पावर्स को, कोई बड़ी बात नहीं है, आप खुद से इसको समझ सकते हैं, प्लीज सॉल्व कर लीजिए. I request as usual that my dear students keep solving with me. It will make the whole session more joyful and you will not feel bored. Okay, let us move towards the next question. Someone from C section, Harsh Narayan, are you listening me? Will you read the next question?
Yes, sir.
23rd question, please, Harsh.
If the first and the nth term of a GP are A and B respectively, and if P is the product of n terms, prove that P square equal to AB to the power n.
Hmm. Right. Harsh, can you repeat the question
If the
once
first
more?
and the nth term
Hmm.
of a GP
Hmm.
are A and B
Okay. Then,
respectively, and if P is the product of n terms,
okay.
prove that P square equal to AB to the power n.
Okay. So this information is given that there is a GP, students, and in the GP, what is happening? That first term is given as A, and the nth term is given as B. This is given, and capital P is the product of these all n terms. Okay. Then to show what? P square is equal to AB whole to power how much? A whole to power n. This we have to prove. ठीक है, तो जरा P को पहले सिंप्लीफाई कर लेते हैं. Right. So this is given. So let me simplify first P. So P equals to, because n terms are there, so A raised to power how much it will become? N, obviously. And into R raised to power, because bases are same, so powers will get added. So R raised to power 1 plus 2 plus 3 plus etc. plus n minus 1 it will become. Okay. And there is a formula, sum of first n natural numbers, n plus 1 by 2. But note that the numbers are not n, they are n minus 1. So n minus 1 into, the formula is n plus 1 whole by 2. So replacing n with n minus 1. So n minus 1 into n will remain whole upon 2. This is P. Because we have to bring P square, so let us square both the sides. So if I square both the sides, it will become P square equal to A raised to power 2n into R raised to power, powers 2 into n minus 1 into n whole by 2, right? And because whole power n मुझे लाना है, तो n मैं बाहर ले लेता हूँ. It will become A square into R into n minus 1 and whole to power n, right? One R I have to keep separate, and other one A I'll keep separate here, and other A I'll mix with this R. So this will become A into A R raised to power n minus 1 whole to power n. And obviously this part is B, this is B. So this becomes A B whole to power n. P square equals to. How? Because B is equal to A R raised to power n minus 1. Right? So that's it. This only we wanted to prove. है ना? So this is the solution of this 23rd question. Ayush Goswami, will you read the next question, 24th question?
Yes, sir.
Ayush, 24th question. I hope students are
Sho-
getting these things. Please keep completing, my dears. Ayush, 24th.
Show that the ratio of the sum of first n terms of a GP
Hmm.
to the sum of the from n plus 1 to 2 nth term is 1 upon r ki power n.
Okay, let me assume the GP. Let the GP is A, AR, AR square, AR raised to power n minus 1, and given that no, not given, to show. What to show? Ayush, can you repeat it? What to show? The ratio of,
The ratio of sum of the nth term first n term to the sum of the n plus 1th term to 2nth term.
Okay. So this is term n, then term n plus 1, then up to 2n terms we have to go. Then
Yes, sir.
what should be the sum of n plus 1th term to 2nth term? ये कैसे लिखें आयुष? इन टर्म्स का सम कैसे लिखूं मैं?
Sir, sum of whole minus sum of nth term.
हाँ, sum of whole thing means 2n terms, s2n minus sum of n terms, sn. इस तरह से लिख देते हैं इसको, है ना, कि n plus 1 terms जो है n plus 1 term, n plus 1th term से लेके 2nth terms तक का जो sum है, that will be equal to the sum of the entire series, entire sequence containing 2n terms minus sum of first n terms. This we have to show. Let us begin. Let us begin with LHS. So LHS is Sn upon S2n minus Sn. Right? Let us use the formula for Sn. For a GP, Sn formula is A r raised to power n minus 1 upon r minus 1. Use it. A r raised to power n minus 1 upon r minus 1 whole upon S2n. S2n will become A, only difference is that in place of n, 2n will occur. R raised to power 2n minus 1 whole upon r minus 1. R minus 1 get cancelled, A get cancelled. Right? No, minus Sn also will come. Minus Sn means A r raised to power n minus 1 whole upon r minus 1. No problem, r minus 1 common and cancelled throughout. A common and cancelled throughout. Now remaining things, let us simplify. This will become r raised to power n minus 1 whole upon r raised to power 2n minus 1 minus r raised to power n plus 1. Right, this minus, this bracket is opened. Here minus 1 plus 1 get cancelled. I think r raised to power n can be taken common. In the bracket, what will I have? 2n minus n. N will remain. R raised to power n minus 1. Okay. Now this factor also get cancelled. So this becomes 1 upon r to power n. Right. What we wanted to bring? This only? Yeah, this only. So this is proved. Right, students? Are you getting, students? Please keep telling. Yes. So A, B, this is a joint class of A, B, C sections. I request you all that do not hesitate. Keep sharing your what you feel. Are you getting or not getting, like that? All the students, let us get ready for the next question. The next question is 25th question. Yes, Shubham. Yes, he's saying yes, sir. Okay. Let me call someone else from C section only. Irshad Hussain, can you read the next? Yes, Irshad. Can you read the next question? Irshad, are you listening me? Some issue is there with Irshad. Om Mahajan, Shivam or Hitesh Kumar? Any one of these three? Irshad, can you read the next question? Some issue is there with his microphone. Hitesh, Deepak Kumar, Ambika Shringi. No response from C section. Ambika Shringi, no, not chat. I am asking Ambika. I am asking to read the question. Can you read the question? Next question, 25th, Ambika. Ambika is responding through chat. Ambika, is your mic working? Sorry, sir, I always take class on PC. I'm again requesting. I appreciate the people, those students who are taking the class on PC or smart TV. It is very good because you will get a nice big view. Good, but mic also can be arranged. It will not be so difficult. Hitesh, is your mic working? Can you read the next question, Hitesh? Hitesh? Yes, good, Ambika. Yes, Hitesh? Can you read the next question? Some activity on his microphone I can see, but no response. Okay. Yes. Saksham Jain, can you read the next question? Saksham Jain, Rajesh Verma or Soumya Bharadwaj? No voice, no voice I can hear. This is not good. Tanmay Meena or Vishesh Singh Raghav, can you read?
Yes, sir.
Tanmay is active. I request all my dears, all my ABC section students, mic, please, voice if it is there in the live lecture, it will increase our enthusiasm. So through voice, because this is joint class, A, B meeting is separate than C. So C people can't read the messages of A and B and vice versa. So like that. Tanmay, 25th question.
If A, B, C, and D are in GP,
Hmm.
show that A square plus B square plus C square
Hmm.
into B square plus C square plus D square is equal
Hmm.
to AB plus BC plus CD whole square.
Okay. 25th, am I right?
Yes, sir.
This I have to show. So let me write explicitly to show statement and given statement. Also clearly, let me write. Given is that A, B, C, D are in GP. A, B, C, D are in GP. स्टूडेंट्स ये क्वेश्चन मैंने पहले भी सॉल्व किया है पहले पिछले ईयर्स में दूसरे बैचेस के साथ. Once I took A, B, C, D are in GP, it means that once I took like this, that B upon A equal to C upon B equal to D upon C, and यहाँ से मैंने निकाला B square equal to AC, और यहाँ से मैंने निकाला C square equal to BD, और यहाँ से मैंने निकाला BC equal to AD. ये तीन इक्वेशन, और फिर इनको मैं सिंप्लीफाई करने में जुट गया लेफ्ट साइड को टू ब्रिंग द राइट हैंड साइड, बट इट टुक टाइम. इस तरह से करने में काफी टाइम लगा, है ना. फिर मैंने एक और मेथड ट्राई किया और वो मेथड से फास्ट आ गया. क्या कि A, B, C, D are in GP, so let A is A, B is AR, C is AR square, D is AR cube. That brought the solution fast. So सेकेंड मेथड से शुरू कर रहा हूँ. बाकी आपके सजेशन, आपके व्यूज तो आप सोच देखिए कि विच वन विल बी बेटर. मैं एज्यूम करने जा रहा हूँ 4 numbers आर गिवन इन जीपी. सो लेट मी टेक ए, सिंस A, B, C, D are in GP, so let A is A, but B is equal to A into something R, C is equal to A R square, and D is equal to A R cube. This is. So next, what is the plan? Plan is that begin with left side, simplify. Right side also simplify. Put A, B, C, D in terms of A and R. And we hope that both will come equal, right? Begin with LHS. Left hand side is A square plus B square plus C square multiplied with B square plus C square plus D square. And let us put the value in terms of A and R. So this will become, students, this will become A square plus A, B is AR, so AR whole square. Let me use appropriate brackets, plus C, C is AR square, 2 whole square, multiplied with B square, B is AR square plus C is AR square, square plus D, D is AR cube whole square. Okay. Now your suggestion, students, what should we do? Your suggestion, what should I do next? Students, somebody suggest me how should I simplify this? बोलो बोलो है, बोलो हाउ टू सिंप्लीफाई. एनीवन? मैं इसको कैसे क्या किया जाए स्टूडेंट्स, आपके सुझाव. ज्योति, मीना, मीमांसा, सैनी, कैसे इसको सॉल्व करें? ज्योति, मीमांसा, सलोनी, प्रवेद, एनीवन? कॉमन कॉमन ले लूं, क्या कॉमन है? ब्रैकेट्स में, इंडिविजुअल ब्रैकेट्स में, है ना? राइट। तो मेरा यहाँ पे नोट कि दो ऑप्शन है मेरे पास। एक तो मैं कॉमन ले सकता हूँ, दूसरा ऑप्शन है कि भिड़ा दो, मल्टीप्लाई करा दो। So if you multiply, three terms first bracket and three terms second bracket, the total 9 terms will generate. 9 terms means more confusion. So I would suggest that avoid multiplying. It will create more confusion only. We can take common. Her suggestion is good. Let us take common. A square common, obviously A square only. And in the bracket, I'll have 1 plus R square plus R raised to power 2 into 2, 4. This is. And from the second bracket also, A square is common. And R square is also common. If you see here, R to power 4, here R to power 6 is appearing. So A square, R square is common. And in the bracket, I'll have this entire term is out. So 1 plus from here, A square is out. R raised to power 4 it is. R to power 4 basically R square out. So R square will remain. Plus this is 3 into 2, 6. R raised to power 6 may say R square out. So 1 plus R. So R raised to power 4 will remain. Right? We can mix these two. So this becomes A raised to power 4 R square into these two brackets are same thing. So 1 plus R square plus R to power 4 whole square it will become. Because these two brackets are exactly same. So this is my LHS. I think it's good if we simplify RHS separately and then we will try to prove that they both are equal. So let us let us begin with RHS. RHS is this. So right hand side is AB plus BC plus CD whole square. Let us put the value of A, B, C, and D. A is as it is A, B is AR, C is A R square, and D is A R cube to whole square. And if you simplify, this becomes A square R plus A square R cube plus A square R raised to power 3 plus 2, 5 whole square. Right. Now also something is common. You can see common is A square R is common. So A square R out. And out of the bracket, whole square will appear. A square R whole square will come common. This is. And inside the bracket, A square R entire term is out. So 1 plus A square out of R cube. R has gone. So R square and A square gone out of R raised to power 5. R chala gaya isme common. So R to power 4 will remain whole square. And this is exactly the left hand side. Right, this is RHS. So we can easily see that left side is quite same like RHS, is it? This also is R to power A to power 4 R square bracket whole square is also there. So, okay. So solving, there can be more ways of solving these questions. I suggest you people that note my suggestion, note this method, and after that you can explore your own methods, your own different ways of solving these. Right now the time is 10:54. I'm going to conclude this class. Thank you so very much for attending this class. You all are my very good students, but let us keep doing our work properly. Let us keep attending our class properly and keep completing our work properly. Notebook work, very essential. And whenever I'm calling your name, respond, very important. Thank you. Do not forget to mark your presence in Google Classroom, right? Thank you. Bye-bye.